Kent Jacobs. FLYHTStream. Derek mentioned it. FLYHTStream is our ability to send data off of an aircraft in flight in an emergency situation. About a year ago, an Air France A330 aircraft was lost over the Atlantic. They don't have the black box or the cockpit voice recorder for this aircraft. They don't know what brought the plane down. There's a small amount of data that was transmitted via ACARS. It does not give the full picture. It doesn't even give a tiny picture of what happened on board that aircraft. The truth is, the world doesn't know what brought the plane down, and that's a problem. That's really, that's bad. The BEA is the French Accident Investigation Authority that is spearheading the investigation, and they have had 3 attempts now recovering the black box. The locator beacon on the black boxes has long since expired, so there is no signal anymore coming off the aircraft or off the black box. They're searching using other means that are not effective, and the truth is they will not find the boxes. We're not going to know what happened to that aircraft. In the wake of that accident, the BEA organized a working group to figure out other ways that the data could be retrieved from an aircraft. Some of it involved ejecting flight recorders while the aircraft was still in the air, and other ones involved sending data while the aircraft was still airborne. They put together a working group. We did not attend the first working group. We were not aware of it. But the second working group was held at the ICAO headquarters in Montreal, and AMS joined it at that point. From that point, we have moved from a participatory role to an advisory role in those working groups. We are actually currently analyzing 43 accidents worth of data here in our office from the BEA, and we will be advising in about a month from now as to how to trigger the data streaming off of the aircraft in flight. At the same time that those working groups were initiated, AMS started a program to see what we could actually stream off of an aircraft in flight. There were some requirements. We had to not modify the hardware on the aircraft. We had to not modify the program running on the ground. We had to use our existing hardware and software platforms. The trials were so successful that we approached the BEA and continued to give demonstrations to them, which further led to Airbus and demonstrations to L3. The BEA was so positive in seeing the demonstration that we provided, the actual streaming of the data, the alerting of the key personnel, the operations center notifications, and most of all, the raw data transfer that we were able to stream off the aircraft. So because we're experts in the world of data analysis on board the aircraft, the raw FDR data, we were able to stream enough data that an accident investigation board would be able to recreate and analyze the accident, even if they didn't recover the black box. And that's what data streaming and what flight streaming is all about. With the data that comes down, the accident investigation boards typically load it into a program like the FlightScape animation and analysis software that's up here, and they can recreate the program, they can recreate the flight second by second. When I showed this demonstration to the BEA, and again, this is not a demonstration of a video, this is streaming the data live from the aircraft, the BEA's response was a very somber, if we had that information for Flight 447, the world would be a better place. The aviation industry would be safer. And that's why they have taken a keen interest in the work that we're doing, and they continue to support us very strongly with this work. This is an actual streaming demonstration that we did. So we pulled this aircraft off, this data off an aircraft on approach. All the instruments in the cockpit are active, and they show what's going on. If we had this for the 447 flight, it would be, the world would be different. We would understand what happened to it. And on the left-hand side of the screen, you see some graphs that are actually displaying a handful of parameters. We send over 250 parameters per second off the aircraft. So there you go. That is the FlightStream program that we've been working on. It lends itself quite nicely into additional programs such as data on demand, and I think Bill mentioned that. An aircraft not in distress can still send all of this information in real time and be used for analysis. So maintenance people can actually activate this system, stream the data off the aircraft, and they will know what the state of the engines or the state of the airframe is. I mentioned the fuel program. So for about a year now, basically since Dick and Matt joined our company, AMS has been considering and working on and developing a fuel program. The fuel program has many components to it. The two biggest parts are the FMS, the fuel management system, and the initiative measuring component of that. We've completed the initiative measuring component of the fuel program. So this is a system that monitors the way the aircraft is being flown, compares it against industry and best practices for efficient operation of the aircraft, and provides the customer with a column, an actual dollar value of a lost opportunity. So money that is being spent on fuel throughout the course of a flight, particularly during the approaches and departures and the ground operations of the aircraft, that they don't need to. A simple example is something like dropping the gear on an aircraft. If you watch the approach onto 3-4 in Calgary, you'll see that the gear on most aircraft is typically dropped somewhere around downtown as the aircraft comes abeam downtown. Every now and then you see one flying around Fish Creek with the gear down and some flaps out. That's an incredibly expensive maneuver. It's just wasted fuel. The aircraft was not configured properly or not configured in a timely manner for the approach. This system measures all of those initiatives and reports it through a dashboard in a really simple way for people to use. The column on the right with the red numbers, and again, you probably can't see them, it's a no-brainer. This is an extremely good use of the AFIRS technology, transmitting the data via Iridium and getting it into our uptime server where we can actually provide value to the customer. It's an impressive program. We like this one. Any questions on the first page of the fuel program? No. This is the final slide that I was going to show. It's part of the fuel program. It's actually part of the same initiatives that I showed you before, but it also goes directly into our fuel management system. The fuel management system is a program that we have fully defined and we're beginning implementation on right now. We're working on the user experience with it, so we've engaged a third party to help us who are actually experts in user experience development. So they're helping us with the flow of the program, the user experience as they log in and move through the program. This is, at the top, it's APU tracking AFIRS only. We have the ability to take raw data from aircraft as QAR data and actually analyze it. QAR stands for Quick Access Recorder. It's the black box data, and use that data and run it directly into our fuel program. We get most of the benefits of the fuel program by doing that. This lets us offer this program to companies that currently don't have an AFIRS unit installed. So it lets us approach the really big players. This program is developed not just for the small ones. This is what we want at British Airways or at Qantas. This program lets us use their raw data to demonstrate how effective the program can be, and then actually, once we get them hooked on it, get the AFIRS unit installed and actually continue to provide a little bit more, not a little bit, quite a bit more value with the AFIRS unit over their raw data. Yeah. So that's that's the state of the fuel program. It's moving ahead. Development is, as I say, part of it is actually developed and operational right now. It'll be demonstrated again in China in the coming month with their data. We have data from their 737 fleet that will actually be running in the program. The APU is a gas turbine engine. It's located usually in the tail of the aircraft. It's used to warm and cool the aircraft when the aircraft is on the ground at a gate. It's used for to provide electrical, air conditioning, things like that. They're expensive to operate. They burn in the order of 2 gallons per minute of fuel. Now, if you have ground power connected to an aircraft, there's no need to have the APU running. But one of the measures, one of the initiatives that we've provided is a continuous measure of the APU usage while the aircraft is on the ground. That's incredibly expensive to burn 2 gallons a minute of fuel when you don't need to. Airlines have no idea if these things are operating. So when you walk over, when you're at the Calgary airport and you look out and you see an aircraft with the little heat trail coming out the back of the plane, it's parked at the gate, the APU is running. Now if that's got ground power, it's highly unlikely that they actually needed that, and it's costing the airline a lot of money. This is a system that measures that and reports it.